So we've seen that writing electron configurations, even though it's a shorthand, can get kind of long. So for example, here we have rubidium, which has 37 electrons, and its electron configuration is pretty lengthy. So what we're going to look at is a shorthand way of writing electron configurations, which is known as the condensed formula. I call it the noble gas shortcut. And what we do is we use the previous noble gas to help us represent some of the electrons. So let me explain more clearly exactly what I mean. Let's look at the first four noble gases. And remember, the noble gases are the last column or the last family on the right of the periodic table. What makes the noble gases so special is that they have completely filled subshells, and that is what makes them so incredibly stable. Filled subshells are very, very stable. So what we're going to do is we're going to use this idea or this concept that they have filled subshells to help us take some of the work out of electron configurations. So for example, let's look at aluminum. Aluminum right here has 13 electrons. If we look at the previous noble gas, one period up and all the way to the right, we have neon. We know that neon has all filled subshells, and so neon is going to be our shortcut for the first 10 electrons of aluminum. So if we write out the electron configuration for aluminum, our 10 electrons have the same, our first 10 electrons have the same configuration as neon. So what we do is we simplify this by putting neon in brackets and then writing the rest of the electron configuration. So how do we know what comes after? Well, we use our periodic table to help us. So here's aluminum. Our previous noble gas is neon. That's going to take up our first 10 electrons. What electrons come next? Well, after neon, we have our third energy level, and this is our S block. So we have 3s2, and we come over here, and here's our P block, 3p1. So that's how we know what comes after. And if we count our electrons, 10 plus 3, we get 13. Let's look at potassium. Potassium has 19 electrons. The previous noble gas, one period up and all the way to the end, is argon. Argon is going to take care of the first 18 electrons. Where did the rest, or that one remaining electron, where does it go? Well, after argon, we're in our 1, 2, 3, fourth energy level. This is our S block, and it's our first column, so it's 4s1. So here are 18 electrons, our first 18 electrons, all filled subshells, same electron configuration as argon. So we put argon in parentheses, and then our last electron, 4s1, goes on the end. Now let's look at technetium. Here's technetium, 43. We look at the previous noble gas, one period up and all the way to the right, that's krypton. Krypton is going to take care of the first 36 electrons. Where do the rest of them go? Well, after krypton, we're in our fifth energy level. And here's technetium over here. So 5s2, and then this is our D block, and our D block is always one energy level less than the period we're in. So 41, 42, 43, 45, 46. Okay. Right? 1, 2, 3, oh no, 5. I can't count. 1, 2, 3, 4, 5. 41, 42, 43, 44, 45. Okay, Miss Perkinson. Okay, so here is krypton, our first 36 electrons, all filled subshells. And then we have 7 left to go. And according to our periodic table, 5s2, 4d5. So go ahead, get out your periodic table if you don't have it out already, and pause the slide to figure out the electron configuration for the following elements using the condensed formula, which I call, as I said, the noble gas shortcut.